Problem 101 involves a pump that's located near the edge of a horizontal platform as shown in this figure over here. So there's the pump. Um, the nozzle at A right here discharges water with an initial velocity of 25 feet per second at an angle of 55 degrees with the vertical. So it's 55 from the vertical. Note that that's different from most time when we're given an angle that's measured with respect to projectile type motion. It wants us to determine the range of values of the height h right here for which the water enters the open area right here, this pit. Okay. So the givens to us are that we got the initial velocity of at A is equal to 25 feet per second. We're given this 55 degrees, I'm going to call it theta. So when we write down the x equation, x is equal to, remember it's Vx naught times time, and it stays constant because our coordinate system is picked where you get the origin right here at A. So what we have is VA naught times sine theta. Normally that would be VA naught times cosine theta, but since theta is being measured from the vertical, it is assigned. And so you get T times T there. So if you solve for T out of this, you get X over VA naught sine theta. Now what we're ultimately trying to do is get an equation of the path of this water here. So we'll look at the Y equation for the same sort of thing. It's going to Y equal to Y naught, which Y naught is 0. And then we have the V naught times the sine of theta normally, but it's cosine of theta in this particular case, again, because we're measuring from the vertical, times time minus 1/2 GT squared. Well, when you plug in this right here into T, you'll get the VA naughts canceling out. And you'll have cosine theta over sine theta, which is cotangent theta. And then you'll have your minus 1/2 GT squared, and the T squared is going to be, you're going to have G, and then the T squared is going to be X squared over VA naught squared times sine squared theta. Okay. That's all equal to the Y value. The Y value over here at the pit is Y equal to a minus H since we had the origin up here. So Y is going to be equal to a minus H right there. And so all you do at this stage of the game is everything is known in your equation. X is going to be 20 feet. And when you have X equal to 20 feet in the first case, and you plug it into this equation right here, you'll find that H comes out to be 1.352 feet. Then you have another X that's 24 feet to get over here to this side. You plug that into the equation right here and solve for H, and you'll find H is 5.31 feet. So what you have here then is a range of values of 1.352 feet is less than H, but H is less than 5.31 feet. So H is greater than this amount, but it's less than that amount right there.